Welcome to COIS ADMN 1620, Introduction to Information Systems. This is Chapter 12, Business Analytics. Learning Objectives. Use a decision support framework to demonstrate how technology supports managerial decision-making at each phase of the decision-making process. Describe each phase of the business analytics process. Provide a definition and an example for descriptive analytics. Provide a definition and an example for predictive analytics. Provide a definition and an example for prescriptive analytics. And identify and discuss two examples of presentation tools. Chapter Outline. 1. Managers and decision-making. 2. The business analytics process. 3. Descriptive analytics. 4. Predictive analytics. 5. Prescriptive analytics. And 6. Presentation tools. Opening case. Stitch Fix. What we'd like you to think about here is how many different types of data are Stitch Fix and the fashion industry using, and how much of the data being disclosed by customers could be considered private or confidential. Why? Introduction. Business Analytics, BA, and Business Intelligence, BI, with user-driven analysis. Business analytics is the process of developing actionable decisions or recommendations for actions based on insights generated from historical data. Business analytics examines data with a variety of tools, formulates descriptive, predictive, and prescriptive analytics models, and communicates these results to organizational decision makers. There's a great deal of confusion between the terms business analytics and business intelligence. Business intelligence has been defined as a broad category of applications, technologies, and processes for gathering, storing, accessing, and analyzing data to help business users make better decisions. Many experts argue that the term should be used interchangeably. The authors of the text agree. For simplicity, we're going to use the term business analytics throughout the chapter. Managers and decision-making. We're going to talk about the manager's job and decision-making, why managers need IT support, and a framework for computerized decision analysis. The manager's job and decision-making. The three basic roles of a manager, according to Mintzberg 1973, are interpersonal, informational, and decisional. Interpersonal roles include figurehead, leader, and liaison. Informational roles include monitor, disseminator, spokesperson, and analyzer. And decisional roles include entrepreneur, disturbance handler, resource allocator, and negotiator. Figure 12.1, the process and phases in decision-making. This is a general model of decision-making. The decision-making process starts with the intelligence phase, in which managers examine a situation and then they identify and define the problem or opportunity. In the design phase, decision makers construct a model for addressing the situation. They make assumptions that simplify reality and by expressing the relationships among all of the relevant variables. Managers then validate the model by using test data. Finally, decision makers set criteria to evaluate all of the potential solutions that are proposed. The choice phase involves selecting a solution or course of action that seems best suited to resolve the problem. This solution, the decision, is then implemented. Implementation is successful if the proposed solution solves the problem or seizes the opportunity. If the solution fails, then the process returns to the previous phases. Computer-based decision support assists managers in the decision-making process. Why managers need IT support? Decision-making is difficult due to the following trends. The number of alternatives is constantly increasing. Most decisions must be made under time pressure. Increased uncertainty in the decision environment, making decisions more complex. And it's often necessary to rapidly access remote information, consult with experts, or conduct a group decision-making session. A framework for computerized decision analysis. We have three elements: the problem structure, the nature of decisions, and the decision matrix. The problem structure can be broken down to structured, semi-structured, and unstructured. The nature of decisions is such that there are three broad categories of managerial decisions: operational control, management control, and strategic planning. Structured decisions deal with routine and repetitive problems for which standard solutions exist, such as inventory control. Unstructured decisions have to deal with fuzzy or complex problems for which there is no cut and dried solution. An unstructured decision is one where there is no standardized procedure for carrying out any of the three phases. In making that kind of a decision, human intuition and judgment often play an important role. Typical unstructured decisions include planning new service offerings, hiring an executive, and choosing a set of research and development projects for the coming year. Between structured and unstructured are semi-structured decisions, in which only some of the decision process phases are structured. Semi-structured decisions require a combination of standard solution procedures and individual judgment. Operational control is executing specific tasks efficiently and effectively. Management control is acquiring and using resources efficiently in accomplishing organizational goals. And strategic planning is the long-range goals and policies for growth and resource allocation. Figure 12.2, Decision Support Framework. We have structured, semi-structured, and unstructured, and operational control, management control, strategic planning. And the fourth column is IISCE support, which demonstrates the sort of IISCE support that could be expected in each kind of decision in the matrix. The business analytics process. Business analytics are the process of developing actionable decisions or recommendations for actions based on insights from historical data, using applications, technologies, and processes. Three specific analytics targets that represent different levels of enterprise-side change are the development of one or a few related analytics applications, the development of infrastructure to support enterprise-wide analytics, and the support for organizational transformation. The development of one or a few related analytics applications. This target is often a point solution for a departmental level need, such as campaign management in marketing. In this example, sponsorship, approval, funding, impacts, and benefits typically occur at the departmental level. For this target, organizations usually create a data mart to store the necessary data. They must be careful with the data mart. An independent application does not become a data silo that stores data that are inconsistent with and cannot be integrated with data used elsewhere in the organization. The development of infrastructure to support enterprise-wide analytics. This target supports both current and future analytics needs. A crucial component of analytics at this level is an enterprise data warehouse. Because that is an enterprise-wide initiative, senior management often provides the sponsorship, approval, and funding. The impacts and benefits of this are felt throughout the organization. Support for organizational transformation. With this target, a company uses business analytics to fundamentally transform the ways it competes in the marketplace. Figure 12.3, the business analytics process. Regardless of the scope of business analytics, all organizations employ a business analytics process, which is depicted here. Starting from the left-hand side of the diagram, the entire business analytics process begins with a business problem, which we often call pain points. When we face business problems, we often turn to business analytics through the process illustrated in this figure. Before we begin our discussion of the business analytics process, let's emphasize the importance of the technologies that underlie the entire process. Microprocessors are becoming increasingly powerful. See Technology Guide 1. In particular, graphics processing units are essential to neural networks, another underlying technology in the BA process. Technology Guide 4 has a discussion of neural networks. Advances in digital storage capacity and access speed are driving the cost of storage down, so most organizations are able to store and analyze huge amounts of data. Transmission speed in computer networks, particularly the internet, is rapidly increasing as well. Therefore, decision makers are able to collaborate on difficult, time-sensitive decisions regardless of their locations. Other underlying technologies include machine learning and deep learning, which are discussed in Technology Guide 4. In the data management box, the important concept here is that we need to have an awful lot of data. Because organizations are able to analyze rapidly increasing amounts of data, we are equipped to be able to do that. Going back to Chapter 5, we learned that these data originate from internal sources, such as structured data in relational databases, and external sources, such as unstructured data from social media. We, as an organization, are now able to combine and analyze structured and unstructured data from many sources in the form of big data. Descriptive analytics, predictive analytics, and prescriptive analytics. Organizations perform 3 types of analytics applications. We are going to talk about those separately shortly. These analytics output to presentation tools. In general, data scientists perform these analyses. Many organizations have employees who translate the results of these analyses into business terms for the decision makers. These employees would often use presentation tools in the form of dashboards to communicate the message visually. We will discuss dashboards and other presentation tools a little further on in this lecture. Once the analytics process is completed, the results are obtained and presented. Decision makers must be ready to ask the next question. Everyone involved in the business analytics process must use their creativity and intuition at this point. Additionally, the results of the BA process will almost always lead to new unanswered questions. Business analytics tools. Excel, multidimensional analysis, also called OLAP, data mining, decision support systems, statistical procedures, descriptive statistics, affinity analysis, linear, multiple, and logistic regression, and others. Excel is the most common and popular tool that's used in BA, and most BA vendors that are making more sophisticated software typically design their software so that it interfaces with Excel. Descriptive analytics. Descriptive analytics summarizes what has happened in the past and enables decision makers to learn from past behaviors. Business analytics tools in descriptive analytics are online analytical processing, OLAP, which, as we've previously discussed, is multidimensional analysis, data mining, and the decision support systems are used for sensitivity analysis, what-if analysis, and goal-seeking analysis. It's About Business 12.1, Insight for Care. What we'd like you to think about here is, how are different stakeholders, the doctor, the patient, the pharmacy company, and the insurance company, affected by the use of Insight for Care? And how does the infrastructure of electronic medical records, EMR data, facilitate the use of Insight for Care? Predictive analytics. Predictive analytics examines recent and historical data to detect patterns and predict future outcomes and trends. Examples of fields where data mining applications are used: retailing and sales and banking, manufacturing and production, insurance, police work, healthcare, marketing, politics, weather, and social good. Data mining refers to the process of searching for valuable business information in a large database, data warehouse, or data mart. It can do 2 basic operations. 1, identify previously unknown patterns, and 2, predict trends and behaviors. The first operation is a descriptive analytics application, and the second is a predictive analytics application. It's About Business 12.2, Analytics to Help Online Retail. What we'd like you to think about here is, how was Aldo's use of business analytics a win-win situation for the company, for customers and for employees? And how could business analytics help different functional areas at Aldo? Example, sales, warehousing, and accounting. It's about Business 12.3, analytics and online dating. What we'd like you to think about here is, if you are or were single, would you use an online dating service? Why or why not? And how much information would you be willing to share with such a service? What concerns, if any, would you have for the privacy of your data? It's about Business 12.4, the Los Angeles Police Department's use of predictive policing. What we'd like you to think about here is, what are some other places where systematic biases could be an issue in our culture or society? And how could predictive analytics algorithms be modified to reduce or eliminate systemic biases? Prescriptive analytics. Prescriptive analytics goes beyond descriptive and predictive models by recommending one or more courses of action and identifying the likely outcome of each decision. Requires predictive analytics plus actionable data and a feedback system to track the outcome produced by the action taken. Business analytics tools in prescriptive analytics are statistical procedures, which include optimization, simulation, and decision trees. It's about Business 12.5, United Parcel Services' 3 types of analytics. What we want you to think about here is, how did the use of IT, the BA systems, help to integrate the UPS operations? And how did wireless technologies such as GPS and handheld devices enable UPS to implement its operational improvements? Presentation tools. Dashboards provide easy access to timely information and direct access to management reports. Their characteristics include user-friendly, supported by graphics, and enables management to examine exception reports and drill down into detailed data. Table 12.1, the capabilities of dashboards. The capabilities are on the left-hand side with a description of the capabilities on the right. The drill down capability is the ability to go to details at several levels. It can be done by a series of menus or by clicking on a drillable portion of the screen. This allows you to zoom into the data. Critical success factors, CSFs. The factors most critical for the success of a business. These can be organizational, industry, departmental, or for individual workers. Key performance indicators, KPIs. They're the specific measures of CSFs. Status access. The latest data available on KPI or some other metric, often in real time. Trend analysis is the short, medium, and long-term trend of KPIs or metrics which are projected using forecasting methods. And exception reporting, which we've talked about previously. They are reports highlighting deviations larger than certain thresholds. Reports may include only deviations. Figure 12.4, Sample Performance Dashboard. This gives you a visual idea of what a dashboard looks like. They can use a bunch of different graphics, including scatter graphs, pie charts, just about anything you can imagine. And it just depends on what allows the data to be visualized effectively as to which type of presentation they're going to use. You may also have choices as to how the data is presented. Figure 12.5, Bloomberg Terminal. This is an outstanding example of a dashboard. Bloomberg's a privately held company that provides a subscription service that sells financial data, software to analyze these data, trading tools, and news. All of that information is accessible through a color-coded Bloomberg keyboard that displays the desired information on a computer screen, either the user screen or one that Bloomberg provides. Users can set up their own computers to access the service without a Bloomberg keyboard. The service plus the keyboard is called the Bloomberg Terminal. Figure 12.6, Management Cockpit. This is a unique and interesting application of dashboards to support the informational needs of executives. Essentially, the Management Cockpit is a strategic management room containing an elaborate set of dashboards that enable top-level decision makers to pilot their businesses better. The idea is to create an environment that encourages more efficient management meetings and boosts team performance through effective communication. The dashboard graphically displays KPIs and information related to critical success factors on the walls of a meeting room, which is called the management cockpit room. Geographic information systems. Geographic information systems provide computer-based systems for capturing, manipulating, and displaying data using digitized maps. They enable geocoding. Every record has an identified geographical location. The example from the text is when the Toronto Police Services decided to develop a tool to improve the understanding of policing, increase transparency, and enhance confidence in the Toronto Police Service. It found that using geospatial data can help it accomplish this mission, and the result was a public safety data portal built using GIS software from ESRI. This tool provides a platform that has easily accessible, useful, and timely crime data. This data includes shootings, homicides, major crime indicators, and it's all included in the app. In addition, users can select a set of dates, types, and neighborhoods based on which the app will query the dataset and visually depict the results on a map. The app's used by various users, such as researchers, media outlets, university professors, students, and residents concerned about public safety in their neighborhood. The Vancouver Police Department has developed something similar. Closing case, dark analytics. What we'd like you to think about here is, how can dashboards facilitate the analysis of unstructured data? And what types of dark data do you provide to the internet and to other IT systems? That brings us to the end of this chapter's lecture. Thank you for your attention.